let's get started. I couldn't. You didn't want me to leave my remote out, so I put it in my pocket, and then I couldn't remember where I put it, which is great. So I want to start by telling a little story here. It starts when I was discussing sorbet with a coworker, as you do if you are me, and part of my job is discussing sorbet with coworkers and offering guidance as to when teams use sorbet. And this coworker was really pushing on the runtime type checking that they get from sorbet. And he presented me a problem that I am going to, he presented me a very abstract problem. I've converted this a little bit to a more concrete problem. And let's see if we can do this here. So imagine I have a very, very simple Rails application. It is called Cookie Cutter. This is the application. Both the application and the slides are pinned in the Slack channel, by the way. I'll get to them in a second, but if you want to follow along, there's really not much to the application. If you want to just open it in GitHub and trace through the walk through reading the code as we go along in GitHub, that's great. If you want to download the site and look at it in your code editor, also great. Whatever works for you. This was meant to be low latency, low typing, high interaction. So we're gonna talk. But here's the issue. I have this Cookie Cutter app. It sends a bunch of things. So Bruce and Clark, they're connecting a bunch of stuff. It creates an order and it prints an output, which is all great. This all works fine. And let me show you how it works. So here's where the code sample is. It's /null rappin /cookie cutter. It is also, as I said, pinned in the Slack channel, and we're starting in the branch called start. Anyway, so there's this web service. The controller calls this web service. It's called checkout action conveniently, and it takes a buyer and a recipient, which are both an internal active record type called person. It takes a bunch of line items. It takes a bunch of promotions. Their type is not exactly relevant for this at the moment. It calls a managed payment service with the same set of objects. And then after the managed payment is called, it then creates an order. Some of you who have done payment services already are already cringing at this, but we will carry on. Let's just assume that this is where we go. The managed payment goes off and it calls another web service called handle shipping. It actually manages the payment. We're hand waving that in a comment because this is not a real app. This is a toy problem. And it calls a third web service that actually prints the label. And at this point, it actually invokes the recipient for the first time. And this all works well and good in process. And then we imagine one day in the future, this app gets really wildly popular and we start taking in third-party people can start sending us JSON API. So somebody else comes along and writes a batch processor for this service. Okay? And it looks like this. This is the same process. It's calling the same checkout action. It's calling internal methods for buyer, recipient, and line items. And you can see the buyer and the recipient here, right here. So what's the problem with this? What's going to happen when this code runs? Looking at what buyer is doing and what recipient is doing and the difference between what they're doing. Yeah, sorry, Mike. Huh? Recipient is going to return. Yeah. Huh? Yeah, huh? Right, so recipient is returning an ID or a string or a something, and buyer is returning a person, right? Huh? So whereas in the past, the previous code was expecting the buyer and the recipient to both be people, person objects as they come in through the checkout action. In this case, the buyer is returning a person object, the recipient is just returning the string. If I put it this way, it looks pretty bald that this is what's happening here, but you can imagine this as being part of a complicated system where somebody just misses it, right? And then what happens, this doesn't work. Specifically, and I can show you here, there's a rake task. And the rake task breaks because a string doesn't have an address, right? And like sort of more to the point, the big problem here in this toy contrived problem is that it breaks after the payment has been made So the payment has been charged, the order has not been saved to the database, and we have crashed. This is bad. And so the question was, and I've obviously this was presented to me as like a skeleton problem. I have sketched this out into like an entire scenario so we can all feel bad for the poor person who wrote this code. But the initial question is like, how do you fast fail then without type checking? How do you know at the beginning of that process that something at the end of that process is going to use an attribute that you don't have if you don't explicitly use sorbet or some other runtime checking? And my immediate response to this was, well, this is a design problem, in part because that's my immediate response to anything. But I did come to think of it, and I started to think seriously about what runtime type checking and static typing checking gives you in a problem like this, what it costs you in a problem like this. And that's what we're going to go over here. No static types, no problem. I am Noel. This is, you've all already introduced myself, but here we go again. I hope you're up for this. This is, as I said, the code sample is here at Cookie Cutter. And this is a contrived example. And that's one of the reasons why we're not going to be doing a lot of typing against it. It's like, it's a Hollywood backlot. There's like the fronts of buildings and nothing else. If you peek around the side, it's just wall. Within that, but I think we can all understand how this might be part of a larger system. And I'm asking you to both sort of use your imaginations about how this would be embedded in a more complicated system. And I'm also asking you, as we go through the different options and the different ways of dealing with this in terms of types in Ruby and in the Ruby ecosystem, comments, questions, like if you see something and you like it, if you see something and you don't like it, like I'm hoping that we can have a discussion about this stuff as I present options that people can react to them. So I want to start with like a really basic question. What's a type? How many bytes you need to allocate? A type is how many bytes you need to allocate. Bing, that's the first one. Thank you, not audience plant. Initially, I think historically, this is what types actually were for. And if you look at C or assembly or something like that, that's basically what you do. If you declare something to be an int in C, you're not really making a strong statement about what kind of value that is. You're making a statement about how much memory the compiler should allocate when it sees it. You're also to some extent making a statement about how the compiler should behave in interpreting the values that come into it. But especially it is it's cues to the compiler, to the interpreter. That's like I think the like oldest meaning of type in programming. What's another way to define type? A set that you're drawing values from. Wow. I don't have any, there's only two reasons I have. So if you have other definitions, actually, that's not true, I have another one. If you have other definitions, like I've run out of magic. But yeah, so I think this is the way we understand it in TypeScript, in Crystal, in Java. If we declare something to be an integer or a Python with type hints, what we're saying is we are limiting the kinds of values that we expect to come in. An integer can have the value 3, but it cannot have the value Fred. Some languages allow you to make very fine distinctions along this way. Some languages allow you to say this is going to be an even number, or this is going to be a number greater than 0. Like Java does not allow you to do that, but there are languages that do that. I think you can force TypeScript to do that. You can coerce TypeScript into doing a lot of stuff if you're willing to put in a little bit of extra work. And you don't care what it looks like. But yeah, that is another like extremely useful definition of what a type is. Here's a question then. Given that, does Ruby have types? If those are the definitions. Okay, I hear nod. Somebody make the case for yes. Somebody nodded. I heard muttering. I heard muttered yeses. What? What about duck types? Okay, define a duck type. If it quacks like a duck. Okay, so Ruby has duck types where in a sense what we're saying is the subset of valid values that we accept are based on the methods that we are going to call on this object in a very local sense. Am I paraphrasing that correctly? Okay, so that's a yes, Ruby has types, but not in the way that, not in the sense that like a value is not limited by declaring the types, it's limited in context by the methods that are going to be called on that value. Okay. I don't have a slide for that. You beat me. Was there other? Anybody else wanted to make the yes case?
What about like in your example earlier, calling different objects?
Calling different objects. Yeah.
You can't give a hash to an array. That would be the subset of values.
Right, but Ruby doesn't enforce. So the point here is you could give a hash. You could send a hash to an array, and that would violate our expected subtype, but Ruby is not enforcing that necessarily. Like there's not a preprocessor in Ruby that is going to say you are sending a hash and this expects an array, right? Not in the actual Ruby native language. And that's my like Ruby doesn't have type arguments, right? Classes in Ruby are not exactly types. If you declare a variable in Ruby, Ruby is going to more or less allocate the same amount of memory no matter what you put in there. It's going to allocate a pointer to an object, with respect to various weird things that it might do for optimization, but conceptually, pointer to an object. And Ruby does not, by its general nature, Ruby is not validating what those arguments are, except again by calling methods on it. Every single method is in its own sense a type validation. This I got from Joel Draper, who we're going to talk about this a little bit more because this is part of a new gem called literal that we're going to talk about a little bit more. In Ruby, a type is any object that responds to triple equals with a truthy or falsy value. So classes in Ruby are triple equal true to instances of that class, and he is sort of backfilling that to say that triple equals defines a type. Also, the ghosts are trying to get in. Don't worry about it. Pretty sure we'll keep them out. So yes, no, do people buy this? Does this work for people? I see like I see a what? That's a lot of things. Yes. So specifically, he is saying that procs define a type, and that type is made up of all the things that return true against that proc. Yes, he's actually explicitly saying that. Now, at some point, we'll talk about literal, and I'll show why he's explicitly saying that. But yes, he's explicitly saying that a proc defines a type in that subset of values sense. Okay. We had somebody wanted to elaborate on their like unease with this definition.
It's also going to be about we just saw in Who Wants to Be a Ruby Engineer.
Yeah.
Proc triple equals is call.
Yeah.
And so it depends on the definition of the
right.
proc.
And and regex.
Yeah.
Regex is our triple equal, as our ranges, as our directories. I used to at one point know all the things in the Ruby standard library that defined triple equals because I had to know it for writing them down purposes, but I have forgotten it. But yeah, there's a bunch of things. There's a bunch of things that are that define triple equals that do not necessarily correspond to our instinct about what a type is. And I'm asking you to sort of hold on to that discomfort. Like what definitions and models, there's a saying about modeling in any case, that a model can't really be true or false. It can be more or less useful, right? And sometimes that's true of definitions too. Definitions can be false. But definitions in this sense can also be more or less useful. So I want you to sort of think about what is useful about this definition of what a type is. What does it allow us to do if we think about types in this way in Ruby? And we will come back to that. This isn't really a talk about literal, but we are going to talk about literal at some point. We're going to come back to that. We good so far? Yes? No? Maybe? This is what you signed up for. I really appreciate you coming out here starting at 3:45 on the end of the second day of the conference. And I strive to be worthy of your time and attention. So, okay. there's two type systems in Ruby. I want to get kind of a sense of the room here. How many people here have used sorbet at all? So that is, it's so hard to tell. It's like a quarter of the room, a third of the room. How many people have used it in a production system? It's the same group, actually. How many people have used it in a non-production? No. How many people have gotten extremely angry at sorbet at one time or another? That's more people than said that they used it. You're just mad at its existence. Or maybe you just like went to 7-Eleven and you got to Baskin Robbins, got a sorbet you didn't like, and you're now very confused. So that's about a quarter of the room. People who have used sorbet, what do you like about it? Nothing. Great. This is going to be a very easy. Okay. Yeah.
So it's nice that you can, as you're experimenting with something, you can write all of it without your types, and then once you're sort of ready to set it in a bit more stone, you just apply them over the top.
So incremental typing. I don't have to repeat that because I got caught on microphone. Incremental typing. Somebody else said something over there. Yeah.
This is a more rudimentary answer, but it's nice that you can express whether or not you expect something to be nil. So that kind of constrains what I guess the arguments of a function can be.
Yeah. Does anybody have an answer that's substantially different from that? No. If you evaluated sorbet and you don't like it, what's the thing you don't like about it? Nothing. All right, cool. I got plenty of things I don't like about it, so
Auto-generating RBI files.
Auto-generating RBI files. So that's sort of an implementation detail of its like the way that it interacts with the rest of the world. Okay, so for those of you who don't, I probably should have done this first, but for those of you who don't know what we're talking about, sorbet is a type checking system in Ruby. It is written in pure Ruby. It's an external gem. It's actually sort of a ecosystem of gems. And this is the group that I was talking about. They were using sorbet. This is what it looks like. This is sorbet for. I decided to put all this stuff in slides rather than go back and forth between the code editor. This is what sorbet. This is what the stuff looks like in sorbet. You have to extend a module called t:sig, which contains all the signatures, and then you get this method called sig, which takes a block, which defines all of the parameters here. Just like, do people have questions about what this is doing? Huh? I didn't know that sorbet existed before yesterday. So this is specifically allowing you to make claims about the inputs and outputs of this method. So I am saying this method takes params. It takes a buyer param that expects a person. It takes a recipient. Attribute that takes that it also expects a person. It takes it has a line items argument that is expecting an array of line items, and it has a promotions argument that expects an array of strings. And I'm saying void, which is to say that I don't care. Nobody should use the return value of this. This is Ruby. It is returning a value, but what we're saying is that value should never be used. Okay. That's how you get around. That's how they get around void context in this stuff. Okay. So you can go further, and you can see that this is the batch processor, and the batch processor is also defining its own signatures for each thing. And now I think it's clear that there's a distinction. If it wasn't clear before, it should now be clear that there's a distinction between these two methods. The top one is taking in a hash of string against whatever, and it's returning a person. The bottom one is taking a hash of strings, and it's returning a string. But the thing that it is calling expects it to be a person. So sorbet has a static checking tool that should allow you to catch this from your terminal. It does a static type check of all of your stuff to find things like this. And it also has a runtime type check tool. in case something weird happens with your static type checking. The team that actually I was talking to about this, only uses it for the runtime checking. They're in a situation where they have a lot of different data coming from a lot of different sources. So there's not a lot of like data validation beyond like, hey, this is the thing that comes from here and this is the thing that comes from here. So most of what they need to do is put a label on something and be able to trace that label through it. So sorbet is actually very effective for them in that use case. I don't know whether it's the thing I would choose for them in that use case, but it actually turns out to be like sort of fit for, it's a lot more than they need, but it fits into what they need, if that makes sense. So what happens when you run this is if you run the code, you get a type error. It says the parameter recipient expected a type person. We got a type string with the value 1. And this crucially happens at the time of the method call. So this actually solves the problem that we had, which is that it does fast fail. It fails at the point of the method call. It will also catch nils, and it will catch all kinds of stuff. All right. Another cool thing about this is that RubyMine, I don't know, I think RubyLSP also does. RubyMine will catch this in the editor, which is also nice. It was very surprising to me as somebody who moved away from typed languages like a long time ago, because I am an old person who has been doing Ruby for a while. And when I moved to Ruby, one of the knocks on static type languages like Java was that they were very time consuming to develop in because you had an extra feedback loop. You had to call a compiler, you had to do something like that. Now, it was very surprising to me. I did a social media poll of what do you like about the people who like static type languages, what do you like about them? And one of the things that people like about them is that they get fast feedback in their editor because the editor tooling has gotten good enough, especially and good enough for static languages relative to dynamic languages, that you can get this kind of feedback in the editor. And there's some of you are saying yeah, I know, this is my whole career it's been like this. And some of you are saying, yes, it's magic. Back in the days when dinosaurs walked the earth, we couldn't do stuff like that. And so sorbet is picked up by RubyMine and also I assume RubyLSP, and that works. But what do you think of this? What is this? What is your immediate reaction to seeing, if you opened up a Ruby file and you saw this? I see a look of distaste. Would you care to go on the record with that? Sure. Just a look of distaste. Okay, yeah. I've doubled the lines of code. I mean, yes, because the methods are short, but yeah, I've effectively doubled or at least significantly increased the lines of code. And one of the more consistent findings, empirical studies of computer finding, is that bugs are actually a function of lines of code. Whether those lines of code are high level or low level or type check or whatever, bugs tend to be a fairly consistent function of the number of lines of code that you write. Sorry, you're gonna. You had a reaction to the error message. What did I lose? Yeah.
My thought is that I can fix this by turning it into a string. So
Okay.
it just told you what to do, or just where to look.
It just right now it's just telling you where. It's telling you that the caller and the callee do not match. Which one is right, I think, is beyond the ability of the type system to sort of infer. Right? Yeah. I mean, I think I'm jumping the gun a little bit, but there's a ton of validation that is not going to get caught by any type checking that we plausibly are going to do. Right? Other comments on the look of this, or just the sort of feel of it?
Thanks. I think the readability is tough. With TypeScript, everything can be defined up top, and then you can read the code and the logic throughout. But having it next to the method call or the method definition, it's a little bit of cognitive overload, I think.
So cognitive overload. I find that it does kind of make it hard for me to glance at code and know where the important stuff is. Whether that's just because I'm unfamiliar with it or because it's diffusing the important stuff throughout, I do kind of like to have a lot of stuff on the screen, all the relevant stuff on screen at once, and this makes it a little bit harder. I agree with that. Okay, two more. Yeah.
I guess kind of related to readability. If I were not familiar with sorbet and I saw that, I would not assume that sig do was a type signature for the function underneath it.
Yeah.
I would expect it's a function call with a block being passed in that does something inside C.
Yeah, I think that's fair. So yeah, I think it's not. You kind of have to either understand sorbet or have like an unusual internal sense of what Ruby is doing to get what it's actually doing there.
So I'm not saying this is necessarily a problem here, but in general, you sort of lose the ability to duck type, where you are happy with any object that responds to the methods that the calls that method needs. And with this, you're locking yourself into a
right. So
specific
you're
object.
very explicitly and deliberately taking away the taking like that's not an incidental effect of sorbet. It's like a specific thing that they're trying to prevent. So if recipient becomes like a company because you're shipping it to a company or something like that, you would have to change the type signatures. And maybe that's good. Like there is an argument that, yeah, of course, if you're calling it with a different type, you should update the thing to be aware of it. But that is where you get a little bit of that like friction, where in normal Ruby, in unadorned, untyped, I don't know, uncut Ruby, unpolished, I don't know, whatever. You can do that without necessarily changing the code, and the dynamic type people will tell you that is a great strength of Ruby, and people who are more comfortable with static types will tell you that is terrifying. I mean, like, I frequently have the experience of onboarding people into Ruby at Chime who have never used Ruby before, and you can always kind of tell who are like very into the Java ecosystem, because when you talk about there not being types, there's a very strong sense, you can almost see it in their eyes, there's a very strong sense of like, what is stopping me from doing like, how does anything work in this language? What is stopping this from like going off track? I mean, I almost said off the rails, but what is stopping this from going sideways like immediately the first time somebody looks at it crosswise? And it is like a more than 30 seconds explanation to say like, yeah, we actually do build complicated programs in this, and there are techniques, but they're not the same techniques that you're used to. They're just different. They're different techniques. Then I show them monkey patching, and sometimes people get really. Have you ever had the experience of explaining monkey patching to somebody in Ruby and they get really mad? Like, this is even possible? Anyway, so that's sorbet. Next option, RBS. This is the first party solution in Ruby. This is part of Ruby since the Ruby 3. Whatever, I can never remember offhand. How many people have actually used RBS in any capacity? A lonely hand. One lonely hand. I would guess how many people have used it in production, but it doesn't really have a production footprint. So I'm going to assume that this is completely brand new to all of you. RBS is Ruby's first-party type system. It is designed the way it is in part because Mats did not want type information in the middle of Ruby files. So RBS is a separate file. This is the RBS file for the two classes that we have had under discussion. Does somebody want to say what it looks like this is doing? Monkey patching. This is not. So this is an RBS file, and it is not actually defining these methods. Okay. It looks like an abstract class. It does, doesn't it? Yeah. It is almost like a manifest. It is saying what the methods are in each class, and it is saying what their like type signature is. So you read this to say like, I have a batch checkout class that has an attribute that's a file name that's going to be a string. I have a process method that takes no arguments and returns void, which means don't use the return value. It has a buyer class that takes in order data, which is a hash of string to string and returns a person. It has a recipient method that takes in order data and returns a string. Again, you see the lack of parallelism here. It has a line item that returns an array of line items, and then the checkout action. This is the same checkout action method. We are just here defining. This is doing the same thing that the sorbet code is doing. It's just defining the checkout method takes a person object, an array of line items, and an array of strings. Is that clear? Is this syntax familiar? How do people feel about this syntax? Also, notice this is a completely separate file, so it does not touch the original file. It looks like a C++ header. Yeah, I suspect that's not completely accidental. There, somebody? Was there? So you're looking, I'm pointing at somebody who's looking at me like they were just raising to scratching their back or something. So
I There was complaints about Sorbet being like, I don't want this type signature stuff
Yeah.
in my Ruby file.
Right.
And then that's what you get with RBS. But the problem there is now you have to look in 2 files.
Yes. Right. That's exactly the problem. Now you have to look in 2 files, unless the editors get really smart about it, which is not out of the question. Like it's a tractable problem. But now you have to, and there actually is also an RBS inline tool which lets you have inline comments. I'm not showing it, but it has inline comments, and then it parses those inline comments and generates a real RBS file. So it's like rather than have RBS use the inline comments, it uses the inline comments to generate the file, which either gives you the best of both worlds or the worst of both worlds, depending on what part of the world you like, I guess. So this is what RBS does. And there is a static type. There's not a lot of tooling around RBS. There's a static type checker called Steep, which I actually didn't bother running on this, but I assume it would catch the same static error. It does not have a runtime checker, but RubyMine will pick it up. If you use RBS, if you create an RBS file and you are using RubyMine, this is RubyMine in the branch that has the RBS. Take my word for it. I don't really want to dig into the editor because whatever. But this is RubyMine in that branch, and it is picking up that type error. So what do you think about RBS? Is the reason why you're not using it because you never heard of it, or is the reason why you're not using it because you don't like it, or having seen it, you think like, wow, that RBS stuff, boy, oh boy, we're going to use that. Nobody wants to be the first person to use it, which I think is part of it.
Yeah. Like, why should I invest in learning this new thing when I can write code?
I mean, why are you here?
I consider dynamic types kind of a feature and not a bug.
Yeah, so I mean that comes to like the crux of this entire like workshop, right? You consider dynamic types a feature and not a bug, and some people come to Ruby and they consider dynamic types a bug and not a feature, right? You have succinctly and eloquently like brought to the entire thesis point of what we're talking about here. But I do want to continue to talk about why people, if you don't mind, I will continue, and we'll talk about why, what about this makes some people think of it as a feature and some people think of it as a bug, or both. It can be both at the same time. Like there's no one answer to this question, as much as I would like there to be.
I guess generally I don't want to be an early adopter of something. I'd like to see that there's like some steam behind it before trying.
Yeah, there's definitely a chicken and egg problem here. Nobody's using it. This is true, I think, of a lot of relatively recent Ruby features. Nobody uses them because they're not quite fully baked when they come out, because nobody uses them. There's no real impetus to fully bake them. And we go around in circles. This is RBS, this is Raptors, this is the pattern matching sort of, although more people use pattern matching. But yeah, I think that's a perfectly valid thing. What? You use pattern matching. People use pattern matching. This is not an anti-pattern matching talk. Pattern matching is lovely. Pattern matching is arguably a type check. You didn't like that, did you? Yeah.
No. At what point does it actually apply the type check?
So you have to use a tool. So you use like Steep, or I don't even remember what all. There is an external tool that you run through that will do the static type check for you.
Okay, because I created some gems a while back, and it seemed to have auto-generated at least the RBS infrastructure.
Yes, it does.
And I totally ignored it.
Right. If you ignore it, that's fine.
Okay.
I did note. I learned today that there is a project, an official project under the official Ruby GitHub page that is defining RBS files for gems in the Ruby ecosystem that don't have them. And the reason I learned this is because RubyMine picks them up now. The new version of RubyMine that came out this week will pick them up, which is cool. That means you get some of this type checking against Ruby gems, against calls into Ruby gems without having to do anything, which seems like a win. You don't have to write anything, and you get an occasional warning that you're doing something that's not ideal. Okay. Now I want to talk about ways to not just do the type checking here, but ways to deal with this inside Ruby. ranging from like least impactful to most impactful. And eventually we'll get to it was a design problem. And eventually we'll get to taking a short break. But we're actually doing great on time, which I'm sure you're all very concerned about my time management concerns. So the first option here is just fix the caller, right? There's a bug here because this thing is calling it with a string when it should be calling it with a person object. Just call it with a person object, wash your hands, call it a day. Like the existence of this bug does not imply that you need static typing. It implies that you need better tests, or it implies that you need to just fix this bug, right? And yeah, really, like that, I think that is a perfectly viable, granted it seems very viable in this like dumb contrived case, but I want to point out that like this is an incredibly contrived example. And one of the reasons that it is incredibly contrived is that it is not doing any data validation on that recipient object until the last possible second. I wrote this like sample code a bunch of times, and every time I was like, because I tried to put in like null checks and some other stuff that we'll talk about a little bit later. And every time I did it, I got to a point where, it's actually, every time I tried to make it more of a concrete problem and less of an abstract problem, I was inadvertently like triggering the type error early enough that it wasn't a problem anymore. So like in a real example, you would be doing data validation. Like what are some of the things in this problem that might cause this to fail that are not going to get caught by like we're not going to get caught purely by type checking, right? Whether it's the right person, whether the person exists in the database, whether the address is actually a valid shipping address, whether the zip code is actually 5 numbers, that actually correspond to a real address, whether those line items actually have positive numbers of things to ship. Although I guess you could consider it negative and be shipping from the recipient back to the buyer. That would be a fun way to write the system. Whether those promotion codes are valid promotion codes is not going to get caught by a type check system. There's all kinds of things that are going to get caught in that are reasons why this code might be invalid, reason why the data coming into this might be invalid, that sorbet or RBS or any sort of type static types or crystal or any sort of type system is just not going to catch, right? So like one of my takes here is static typing is a kind of data validation, right? You are specifying in the subset case or the triple equal definition of type checking, you are specifying something about the data. You're specifying that it's a person object. You're specifying that it's a string. You're specifying that it's whatever. But if you have a lot of complicated data validation, like if we have this recipient object and we need to know, like, is the name valid? Is the address valid? Does the person have a PO box? Like, are they even in our database to accept, do we have like a do not ship flag on this person for some reason? Like all kinds of things that might be true. And once you do that, like the piece where it is a person object becomes increasingly implied by all of the other data validation. Like the more data validation you are doing, the less incremental value you are getting from just that piece of static typing. I spent a lot of time trying to teach people test-driven development and object-oriented techniques. And one of the things that is true about teaching testing in particular is that any problem that is simple enough to teach testing to in like a short workshop is too simple to explain the value of testing, right? If you can look at the problem and like go, I know this code just works, like you can just look at it and you don't need the tests, the value of testing comes in a more complicated problem where you don't necessarily know the answer, you can't necessarily evaluate it, where there are a lot of different potential ways where you could regress and not notice it. And I think that in some sense, type checking is the inverse, right? It is extremely easy to demonstrate, as we did. Like I demonstrated in like 7 lines of code. Here's an obvious bug that is obviously caught by type checking, right? And it's very easy to jump to that to say like, oh, type checking must be extremely valuable because it caught this obvious bug in this obvious small case. But I also think that the more complicated the code gets, there's sort of an inverse effect. The less valuable that specific type check get. Now, type checking can have other points of value. It can provide communication. It can provide documentation. There are other reasons to have type hints in the code base. But I think the pure data validation bit gets less valuable as the code gets more complicated. I think the communication value gets more valuable as the code gets more complicated, which is one of the things that makes this discussion a little tricky. So do people have any reaction to the do nothing policy here? Somebody want to take a don't do nothing policy and take a stand as to why this is terrible or great? Or have I finally put you all to sleep? It was inevitable because it's 4:30 on a...
Well, I wouldn't call this the do nothing approach. I wouldn't call this the do nothing. This to me. So when you showed the problem initially, my head went immediately to, wait, there's no test. Like right. So this is the write a test approach, I guess.
Yeah, that's another way in this system is contrived. A real Ruby program would likely but not definitely have tests. Like this is a rake task. As I wrote it, it's a rake task that calls an object. So the object could have tests, but a lot of places don't test their like one-off batch scripts. So it might not. Yeah.
I was gonna say, like, I haven't used either of these sorbet or RBS, but sometimes if I'm looking at some new code, and particularly if they're passing around stuff that's like a hash with a array of hashes, you know, like that, and I'm like, what does this take? You know, like,
sure.
I'm just like, what is valid for this function? You know, like sometimes I would like to have, and without having to go like, okay, well, there should be a test that validates what this thing takes, but then I got to dig through a bunch of R specs and sort of figure it out.
I don't really disagree with any of that. I do think that like this method takes a hash of arrays of hashes is something that is going to be very tough to model in any of these systems. I mean, you just threw that out there. I'm just like, but okay. So type errors like this, in my experience, rarely make it to production except when they do. And at some point we'll talk about what kinds of type errors tend to make it to production. But a lot of these things get caught in development or in early testing because they are, kind of think of them as being loud. Like it's often very obvious what's happening. You get an error and you know the actual error here, the thing that the string doesn't have an address. Like in most cases, like that will come up in early testing and it won't make it to production, which doesn't mean it's not important. Like you're using time on this. But a thing that I often hear from people who are coming from static type languages is like, how do you prevent these things from going to production? And the answer is like they get prevented the way any other bug does. Like we do testing and we evaluate the code. Those errors, like I said, those errors are very visible. And I also think that there's like a certain low-level friction of dealing with types because you can't duck type, specifically in Ruby. Like I think every language encourages certain things and discourages other things. I think specifically in Ruby, these type systems, in my experience, there's a certain like continual friction of having to deal with writing the types out, convincing the type system that you have the right stuff, trying to do flexible stuff and working with a type system that is like another case where it is often true in programming where if there is a lot of time passes between the time you do something and the time you actually pay for it, one way or another, it's very hard to make that connection. So like if you have a really good test suite and as a result, like you can add features really quick, it's very hard to make that connection. Your tendency is just to think, I'm just a really good developer. I can develop these features super quick. And similarly, like the extra cost that you pay for adding these type systems, like you don't even sort of connect it to the initial decision to do the static typing. It just sort of becomes the cost of doing business. Okay. There's an option 1A here, yard. Does people know what yard is? Yes? Okay, you can hold your own mic to yourself. What's yard? Yeah.
Yet another Ruby documentation?
Yep, yeah. So yard is a documentation tool. There's a yard branch if you want to follow along in GitHub. Yard looks like this. This is doing basically the exact same thing that the sorbet and the RBS was. This is the checkout action versions. We can read this. It is defining a param called buyer that takes a person, a param called a recipient that takes a person, a param called line item takes an array of line items, and so on and so forth. An interesting feature about this is that the types don't actually have to be classes. You can actually define a list of methods. So you can actually define a duck type in Yard as being the correct type. What do people think of this syntax? Snaps. Is that good? Snap. Okay. Snaps and thumbs up from the corner of the room. A thumbs up.
I use this in my documentation. I love it for the documenting part of it. The issue is when the next person goes in and changes signatures, they don't always change the comments above.
Right. So the obvious problem here is that there is not a runtime type check tool tied to RBS, tied to Yard. I think a really good project would be a Yard to RBS bridge. I think that would be a really not super hard thing to do. So I'm planting that seed in all of you people and hoping that somebody comes up with it because I think it would actually be doable.
It exists.
It exists?
It's called Sword.
Sword?
S-O-R-D.
Okay. It exists. You don't actually have to do it. You learn something new every day. The other really interesting thing about Yard, so I like the syntax. I like it more than Sorbet's syntax. I think it's less disruptive. I like it more than RBS's, not just because it's in the same file. I also think it's more natural. And you get documentation out of it. You don't get runtime type checking, but at least in RubyMine, you do get type checking in the editor. I was floored when I found that out. I did not know that, and I was writing the book. I was writing the pickaxe book, and I was writing the chapter on Yard, and I created a bunch of Yard things, and then I noticed that RubyMine was flagging type errors just off the Yard documentation, and I had no idea that that was a thing that it did. That's a thing that it does. It's not actually giving you don't have runtime type checking, you don't have static type checking, but RubyMine picks it up in the editor and flags it as an editor error. That is not nothing. Yeah, they must have some sort of very good type engine in the background inferring stuff off of Ruby code. So I think that's pretty useful. That was almost enough to make me start writing documentation. And then I thought that seems hard. Okay. What I think I'm going to do here is I'm going to quickly go through the next couple things because they're very similar, and then we're going to sort of take a left turn. And I think before I do that, I will take the opportunity to give you a 10-minute break. Is that good? You are free to not come back. I'm not taking. I mean, I would like you all to come back, but I was advised, at least in the past, to give a break, and we are more or less at the halfway point, and more or less the halfway point on time. So if that's okay, we will take a short break, and then you can hopefully come back. It goes against my every performer. No, I want to talk about a couple things first. I want to just do the next couple slides first, and then we'll take a break. I'm just floating the idea of a break. Sorry. People were like, I can't wait to get out of here. It goes against every performer instinct to let the crowd go. But we'll think of it as an act break. I'll give you like a hook that will keep you coming back. So, okay, a thing that you could do in Ruby is you could actually explicitly type check. So what's this code doing? Somebody's nodding. Somebody tell me what this code does. What? It's using a guard clause. Yes, it's using a guard clause. Yay for guard clauses. Let's hear it for guard clauses. Do we like this? This works. This will solve the problem. As stated, it will solve the problem. Pretty much every Ruby style guide will tell you not to do this. Why? What's good about this and what's not good about this? What are you going to do when it fails in your production system? You've recognized the problem, but you haven't solved it. Then that's somebody else's problem. You're missing the brilliance of this. Yeah, here. It's been operating. Well, yeah, that's true of the sorbet stuff too. It's an operation that's being done at runtime. Right, that's a definite downside. If you're going to actually do this at scale, you're adding this line for every, like you're adding those things that we found distracting as sorbet as comments are not going to get less distracting as actual lines of code in every Ruby method. And also, duck typing is a feature, not a bug. We've taken away all the duck typing. But there are limited cases where this is a valid thing to do in terms of like, I would keep it away from this kind of code, but there are like factory methods. We'll talk about like factory methods that do use this kind of code, this kind of check. Technically this works. Duck type, you can do this in duck type. So what's this one doing? To the extent that most Ruby styles guides will opine on this, they will say that this is preferable to the previous version. What's it doing? Oh, for crying out loud. Yes. Okay, that's the relevant bit, yes. Calling unless too many times. This is what I get for not running every single one of these. These errors rarely make it to production, Ben.
So we're checking what method we're going to use on recipient, and the problem is how many methods do we need to check?
Yeah. So this has the benefit. So what we're doing here specifically is we are calling respond to. If you assume that I typed this accurately, we're calling respond to against the address method. And again, the problem here was the address method. So this in a limited way solves the problem. It fast fails. It is considered better than the explicit check against the class. Because if I had a company or something else that was a recipient that also had an address, this code would work. But as you point out, I could be calling 10 methods on that thing. Do I want to respond to all of them? Like there's potentially an explosion of checks here. And really, Ruby's already checking that these methods respond to the method when you call the method. Like the only reason to do this is because you want to do the check earlier. And I think that we'll see that there are other ways around it. Okay, so we kind of got this. Before we get into object design, here is my hook to come back from the break. We're going to talk about the 4 things in Ruby that are especially dangerous type-wise, and we'll talk about mitigating them. And I'm going to leave it here, and we're going to come back. It is on my watch 4:40. We'll come back at 4:50 if that's okay. And I will fix my voice and get some water in me and caffeine, and we'll come back. Thank you for your attention so far, and please come back. Anyway, seriously, thank you for coming back. I know that this is long, and I know that it is late, and I know that you have to come back to listen to me. So I very much do appreciate it. So we'll get to the here's like my 4 where I have had type errors that get to production in Ruby. They almost invariably fall into one of 4 categories. Anybody let's see if maybe we'll have the same magic that we had before, where we anticipate my every thought. Survey says
nil.
Yeah, nil is obviously the biggest problem here. It is like mitigatable in many ways, partially just is often mitigated by testing and just sort of being aware of it. There are also various like patterns that we will talk about that allow you to manage it. But nil breaks the object system. Nil is not any of the types you want. You never actually want nil. And one of the like very valid things about using one of these type systems is they prevent nil from getting passed at runtime, which is valuable. I have it in my head to try and work on a Ruby decorator method that would be like, don't allow nils as arguments to this method that would check at runtime. I've never quite gotten around to it, but I think it's doable. Okay, next one.
Int and float.
Int and float. I've never really had a problem make it to production with int and float specifically being a problem, because they generally generally don't register as type errors. They just sort of register as like math bugs. But yeah, you can have a problem with that.
Integer versus string.
I don't see that make it to production. It's definitely a problem. Like it's definitely a thing that can happen. The one that does make it to production is string and symbol. And The specific problem here is I have a hash where the keys are strings. My incoming, everybody, like half of you are like, I'm way ahead of you all together now. And the value is coming from the database or JSON, so it is a string. And so it will never hit the hash that has symbol keys. How many of you are nodding? This is like a ask me how I know. Seriously, I've been doing this kind of thing for a long time, and I've never said something that caused so many sad nods in the audience as that one. Like, oh yeah, I thought I was the only one, but guess not. So this is a problem, and this is a problem that is specific to Ruby because Ruby has symbols, and most other programming languages don't, at least not in the same way. They have interned strings, or they have like immutable strings versus mutable strings, but they're strings. Ruby has them as symbols, and also has symbols that are not equals compatible with their related string. And there's all of this huge ecosystem that just passes strings around. It's particular. There are cases of this that are particularly insidious. The hash can be a cache values, cached values, and then the strings come in and you never hit the cache, and it never fails because it's still working. You're just not hitting the cache. Just everything's like much slower than you expect, and nobody can figure out why. Like this is a real. In some ways, this is like the most insidious one because it's the one that is most likely to fail quietly. Whereas nil often fails very loudly. Related, everything is a hash. If you pass a bunch of hashes around, inevitably you'll get to the point where I know this is a hash, but I expect it to have this key and it doesn't have this key, or I expect this key to be populated or whatever. This also has a tendency to be quiet because you may not notice it for a long time, or you may not notice it under certain situations, and it is super common to just throw things in hashes and pass hashes around in Ruby. It's just like a ridiculously common, definitely like overdone thing to do. And the last one for me, and this may be a me thing, is naming, where I have problems based on naming. And they don't always make it to production. Often these get caught, but they're often very subtle. And were any of you at the Chime sponsor thing yesterday? No? Great. Nobody was. It's very exciting. I talked about a tool that I was doing that is managing gems. That tool has an active record object called version, which is the version number and date of a particular version of a Ruby gem. It also has the version number, which we colloquially call a version, as in version 3 of our spec. They also have a data object associated with them, which gathers data about that particular version, which is called version status. Ruby gems has a version, gem : version, which has the useful feature that it sorts version numbers based on segments. So we use that too. It also that also uses pins, so it has a need for something that can represent what is the top. If you are pinned to tilde greater than 3.1.0, what's the highest version you could have? It's 3.1.infinity. So I have a fuzzy version that can manage 3.1.infinity. That is like 5 classes that you could all colloquially refer to as versions that might get passed. So if I have a variable, if I have a parameter name that is version, unless I'm being very careful, it could be any of these. And they are like somewhat API compatible, but they're not completely API compatible. So you can get, this is something that doesn't often make it to production, but it does sort of make it through your first wave of testing. And then something weird happens and you don't quite understand what happens. And we'll talk a little bit about some of the techniques that work around that. So those are the 4 things. Am I missing? Is there something that somebody has seen in production typing that I'm missing? Yeah. Occasionally cached an object.
Marshall dumped an object, and then the code moves on, and you Marshall load that object, and it won't load into its old thing before. I don't know if that counts as a type error.
Yeah, it's not a type. It's sort of in the same constellation. I don't know how common it is that you would do that, but I could see it. Like I could imagine a case where like you are not even necessarily marshalling, but you're going to like a JSON. You're using a NoSQL database or a JSON column in a Postgres database, and the expected keys have changed, and I could see that also failing quietly for a long time before you get weird subtle bugs. Like my general position about this is that I don't mind something that has a chance of producing loud bugs, but I do like to avoid things that produce like weird subtle bugs. So, okay. So which takes us like neatly to sort of option 4, which is data coercion. Coercion is the general term here for taking one piece of data that you know is one type and converting it to another type according to like a known algorithm. Ruby does not in general do this implicitly, although it does in certain cases. For example, if you splat a method object, it will implicitly convert it to an array. Double splat, it converts back and forth implicitly to a hash. But if you add like string 3 and integer 3 in Ruby, that will be a type error. Other languages will try and guess what you're trying to do and will either do the integer arithmetic or the string arithmetic depending on whim or whatever. Ruby, for the most part, does not do that, at least in like normal method operation. But you can take advantage of that in your own object design. You can create your own coercion functions. And the idea here is rather than being strict about the types that you let in, being generous about it and saying, well, if somebody passes an integer in, they almost certainly mean it to be an ID. I can just look it up, right? So the idea here, sometimes you see this under Postal's law, which is a little bit different in intent, but the idea is be liberal in what you expect, be liberal in what you allow in, and strict in what you put out. So you can write your code so that you are a little bit more forgiving of common type errors, and therefore you solve these problems at a design level by actually coercing these objects to the things you want to do. It can be simple. You can do stuff like this with hash. I wind up writing key to sim a ton in my code. It's a very simple coercion that makes me that solves that string symbol problem. It's a little bit of overhead on my part that I kind of resent having to do, but it does solve the problem. On the other hand, you can also coerce the entire hash if you think it's coming in. Does everybody know what Rails hash within different access is in Rails? Yes? No? So hash within different, in the case people are just nodding to be part of the popular crowd, where the popular crowd that knows what hash within different access is, which is certainly the sign of, never mind. Hash within different access it essentially does that top coercion for you. It looks, if it doesn't find the key, if you pass in a string or a symbol and it doesn't find it as that, it converts it to the other one and then does that lookup. And people have some strong opinions about that, which we will talk about in like 2 slides. And then there's this gem, I have not used this yet, but this is a gem that just popped up like a month or so ago called hash with dot access, which allows you to take a hash and treat it as an actual object. It uses method missing and various other tricks to allow you to dot access a hash. I'm not sure I recommend it, but I kind of like that it's out there. I would do hash with dot access by like converting the hash to a struct or a data object, but that's me. There are a lot of ways to be successful in software and also a lot of ways to fail. So anyway, the idea here is to be more forgiving of what data you accept when things come in. So this is a thing I used to do in Rails applications a lot. What is this doing? What's this line? What are these 3 lines of code doing? Anybody? Okay. Yeah, looking up a user if it's passed an ID. So yeah, we're taking in a user or an ID. If the ID comes in and it's an integer, I'm going off and finding the user that's associated with that integer. Otherwise, I'm just taking the ID and doing stuff. What's good about this? I've ensured that I always have a user, even if I get past an ID. What's bad about this? Or why did I stop using this? I actually stopped. I don't know why I stopped using this. But what's a potential problem here? If you pass the idea of not a user, yeah. If you pass the idea of a company or something else that you have in your, I'm completely blanking on things in a database. The problem here is that if you pass in an ID that is not pointing to your user, you can get in a lot of, you can get a very, very subtle issue. When I was at I think I can tell this. When I was at Groupon, this is apocryphal, so I'm not 100% sure that this happened. It used to be that nil.id in Ruby returned 4. And yeah, and it also was true that Andrew Mason, the CEO of Groupon, had user ID 4 in the database. And as a result, he would occasionally get like a bunch of emails that were going to nil users because the nil would get converted to a 4. They would do nil.id, would get converted to 4, and it would send an email to him or something. Apocryphally, I actually don't know for sure whether that happened, but it was a story that we told. So that's a potential problem here. This is usually the point where someone tells me about their TypeScript program where they made every single object's ID a different type so you couldn't have this problem. And I think that sounds like a lot of work for the occasional misstep here in a cost-benefit analysis. But I also think you actually can get that in Rails. Do you know? Anybody know what global ID is in Rails? Rails global ID, a couple of nods. So Rails has an official, from the Rails team, gem called global ID, and it converts, you get an ID that is like user _ 37 or something like that, and it can convert it to class and object. So essentially it is a global ID for whatever class you want to do. And you can do a couple of other cool things with them. You can cryptographically sign them. You can make them so they're only valid for like a certain length of time. The idea is you can then take it and pass it as like a password. You can give somebody a temporary key for their password, and then you can convert it immediately back into that user ID, and it is invalid after a certain amount of time. It's actually really cool. So with a little bit of judicious monkey patching here, what is this doing? I haven't actually used this in production, but I am tempted. Anyone? So I'm creating a method called findIf that takes in a class, and I'm monkey patching it into both global ID and active record. So you pass it a class, and it does the conversion. Model class is the class of the global ID. I can't believe I just used the pointer. I feel that doesn't make me feel great, I gotta say. And if it's not the right class, it returns a runtime error. If it is the right class, it returns the object. That's basically the global ID API to check the class and return the object. It's doing something similar in active record. If it's the class of the object, it's returning the object. If not, it's returning a runtime error. So then you could say, this method takes a person or global ID, and I can just call findIf on it polymorphically. And if it is a person or a global ID that is of the right class, I will get the right object back. And if it is not, I will get a runtime error. This seems useful to me in like a sort of type-checky kind of way. I think this would be harder to misuse than the previous one, but you get a lot of the same issues. You look skeptical. That's fine. I haven't actually used this in production, so I can't say. One of the reasons I haven't used it in production is that it is a little bit complicated to get Rails to sort of use. Your forms would have to pass global IDs around and things like that. So you have to actually explicitly like turn your application into an application that uses global IDs, and that is not like a trivial thing. It might be worth it, but it is not a trivial thing. So okay. So you can also do this. This is now back, if you go back into the code under the coercion branch, if you're following along, if for some reason you are following along in GitHub rather than just letting this wash over you. This is actually in the GitHub repo. What's this doing? This is part of the person class that we have alluded to but not actually seen so far. Yeah, it's running down a list of ways you might get a person. So if it's a global ID, we're actually checking that for the global ID. And then we're going through and casing the object if it's an integer. We actually are doing direct type checking here, which is this is the kind of case where I do find it sometimes necessary or valuable to directly check against a type. The other option here would be to monkey patch integer and string to have a convert to person method. I would be finding that in code that I was using on a team of me, but I find that if I do something like that too aggressively in a team of other people, they don't like it and they come after me. In theory, what you're supposed to do here is double dispatch to integer or string dot to person But since that would involve monkey patching, and there are good reasons why we don't want to monkey patching, this is like a stand-in for that. By the way, apropos of previous conversation, what is it using to test whether something is an integer, a string, or a person here in the case statement? Triple equals. Yeah. So like very explicitly, a type is being defined by triple equals here. So we could have a proc. Like you could have something here where you had a proc as one of these when statements, and like, I don't know, on Tuesday return a person object, and on Wednesday, you have arbitrary. You can make it arbitrary with this structure. Okay, then you would use this as follows. I'm also mapping the promotions to symbols here to do that coercion. But the real point here is that both buyer and recipient are going through this from pseudo like factory method that is guaranteed to return a person or throw a runtime error. And now I know it's a person. This also solves the problem. It solves it in a different way. Rather than throwing an error, we're actually like performing the order. In general, like doing things that will cause your company to load a sale is preferable to throwing an error, just a little bit. So this is doing, so that's what's happening here. We are guaranteeing that person returns, that from method returns a person. You could actually just check this person method and just say, it takes in an object that is any and returns a person. And you actually can get a little bit of type checking stuff for basically no real cost. Like we know that this returns a person, and if we tell it with RBS or sorbet or one of these, or yard or whatever, that it returns a person, we can get a little bit of benefit from that in our editor as well. Some editors may pick this up, but it's pretty sophisticated to pick it up in general. Okay. What are some pluses and minuses of using this kind of technique? Like, how do you react to seeing this code? If I passed you this as a P, if I came to you and I said I was asked to fix this bug and this was the PR, right? What would your comment be? Many hands. Yes.
What if you get a string ID?
What if I get a string? Yes. So yeah. So right. So I had to look at the code. Like yeah. Yes. I am assuming here that a string is an email. Because I was trying to be cute. But yeah, I could just as easily have a string that refers to an ID, and then this would fail. You're right. That's a good point.
Extensive disgust. No, I worked in these code bases where you never really know what anything is, and so you're always having to add person.from or whatever, and you could have this thing being, a person's passed to one thing, passed to a next thing, passed to a next thing, and each one is calling person.from, like just in case, because you never really know what anything is.
Yeah, so that's a potential downside of this is sort of a cascade where you are continually passing, this around, and you're continually, right? There's kind of a way around this where you sort of like specify, this is where you sort of get into like boundaries. Like, okay, this is a boundary and we're going to do our type checking at the boundary and we're just going to assume type checking here. That takes a little bit of discipline or structure or things that a large team may not be able to do easily. But yeah, that's a potential problem for this. Usually on something like this, the identity clause is right up top. So return a person if it's already a person is up top. So the cost of that is, the performance cost of that is minimal. But yeah, you have to remember to keep doing it, and that's a potential problem.
I would kind of assume, I would ask the writer of the PR, why aren't we just updating the call sites to ensure one or the other?
I mean, we might do both, right? You could evenly do both. I would say because in the case where somebody else makes this mistake, I would prefer to log the sale than throw an error. And we could argue, that's a debate. Like, I think that's a perfectly reasonable, why, this is adding complexity. Do we need this complexity? I think is a perfectly valid question to ask. Someone else? I just want to see people, I'm calling people as far away from Ben's current location as possible. I just want to see what his step count is at the end of the
I mean, you kind of already alluded to it, but my first thought is, what sort of sloppy service boundaries do you have in this application?
What sort of sloppy what?
Service boundaries?
Yeah, so a common complaint against this kind of thing is that it makes the team sort of sloppy. If I don't have to care whether I'm passing around integers or strings or people or whatever, then I won't care. My usual response to that is if I don't have to care, then I don't have to care, and it doesn't matter. But that's glib, and it's the kind of thing that you can say if you are standing up here and not writing production code and just like talking. In practice, like it is a concern. Like it can be a problem. Like you could have the like passing an integer that's not a person ID problem. Like that could easily happen here. The call is person.from. So if you see a line of code that is like person.from company ID, hopefully that will set off an alarm bell. But like you are deliberately, you're making a deliberate choice here to be more permissive. And one of the consequences of that is that people are going to be more they're going to be more flexible in response to how the code goes.
I guess I would think it was okay just as long as, like people are saying, as a team we agreed these things all have like kind of the same identity. Like maybe in email we only allow you to have one email attached to this account.
Right.
And that can be sort of like an alias for the database ID. Because if we're going to be like, well, we need to always use the same thing, then you're going to have to ask people to like, I don't know, in testing and thinking about it, as human beings, always think in this ID, this like long number, which is hard for people to do. I think that's one of the reasons these types of bugs maybe happen.
Yeah, I think the email here is definitely possibly a bridge too far to throw the email in here. It definitely has a little bit of a one of these is not like the others case. Stephanie, you could be nice if you're consuming from one or more third-party services that you don't control. Yeah, right. In some cases, your goal is to try and be resilient. Maybe it's like an overly strong term for this, but in some sense, what you're trying to do is make your code resilient. Like they can throw me whatever weird data, and I can convert it to the thing I want. The side effect is that sometimes you may make a mistake and not convert it to the thing you want, and it is like a case-by-case basis as to whether that's more important or less important than just throwing the error. I can imagine cases where either would be true. So there's a specific thing about hash with indifferent access. I just saw somebody have like a rant on Twitter or something that got passed around about how hash with indifferent access was by itself a code smell. And my response was like, I have been a Rails developer for mumble years. I've been a Rails developer for almost as long as there's been a Rails. Hash with indifferent access has been a part of Rails since that time, and I have had precisely 0 problems with it. I would bet that there is a significant percentage of Rails developers who use params hash all the time and do not even think that there is a thing called hash with indifferent access beyond that. They just use it. And to me, that's great. Like, I don't have a problem with that. That said, like you would think that the implication of that is that I would often use hash with indifferent access in my own code. And it actually turns out that I don't. And I couldn't give you a real good answer why. I tend to use the explicit conversion to symbol rather than explicitly use hash with indifferent access in my own code. I don't have a great reason for that other than perhaps I internalized the idea that hash with indifferent access was a code smell and never really thought about it. Sometimes I can't explain my own actions. But yeah, there's a specific, like this is a specific kind of coercion that is real easy to do, has almost no chance of having a negative side effect. And yet at the same time, some people will be like, no, that's too flexible. I don't know. I find that to be weird. Okay. The next couple of things here talk a little bit about more about objects. What do I got? Like I've got 28 minutes. We're gonna power through this. Let's talk about objects. What's an object? In the same way of like, what's a type? Generically, what's an object? Oh, sorry. People went to sleep. I'm sorry. That's good. Make Ben run. Next, I want somebody up front to answer the next question.
An object is a bundle of code, data, and the things that you can do to that data.
Yeah. Data and functionality together. Right. So Ruby is an object-oriented language. It is made of objects. These objects contain data, state more generally, and the functionality that adapts to and adjusts that state. Y is an object. Y is Gamora. why are objects considered? I was going to say why are objects considered good, but that's not really the question. Why are objects useful?
Gives meaning to bundle of data.
Gives meaning to bundle of data. That's definitely true. It is not the thing I have on the next slide. I'm sorry, but it is unquestionably true. It is not nothing. Like having a name, having all of these things together and calling them a person rather than just calling them a random hash that has a bunch of things has definite communication value. And doing that well and doing that poorly makes a big difference. Yeah. You're the only person who's even close to raising your hand. Composing primitives. Kind of, yes, but it's not really what I'm looking for here. Now you're asking you to mind read me, but somebody will do it. Yeah.
No, can I...
Limits the scope. The fancy technical term for that is encapsulation.
Oh.
Okay. So,
never mind.
What? Somebody's like, I was going to say encapsulation. Darn
no.
it. So the advantage of encapsulation is that it limits what code needs to know about other code. One of the things that makes code hard to update is hidden dependencies. I change this code and I can't tell what other code downstream is dependent of that. Is dependent on that. If you have stuff in methods in an object, callers of that method, at least in theory, don't need to know how it's implemented, and they don't have a dependency on the implementation of it, so you can more safely make changes. Ruby in particular is designed to make certain kinds of encapsulation really easy. In particular, Ruby makes it super easy to go from something being like an attribute, like a simple reader, to a more complicated method without the callers having to care. Like you can change things from local variables to methods without having to worry about it. And then there are certain kinds of refactoring that make encapsulation easier that Ruby's really good at. Okay, so one of my things about Ruby is create instances and create classes and create instances of these classes. So just from a design perspective, I realize it feels like I'm going a little bit afield. I promise we'll pull this back in a second. From a design perspective, if you have a service class, service object in Ruby, broadly speaking, there's 3 different ways to access that. You can create a class method or a module method that doesn't create an instance. You can create an instance, but pass the data, only pass the data at the point of call. Or you can create an instance and pass the data at the point of instance creation and then have the call method create the call. I submit that like 120% of the time you should do the third one. I don't often make like strong pronouncements about what you should and shouldn't do in Ruby because what do I know? And what do I know about your life and your constraints? But the bottom one is like 1,000,000 times easier to test because you can separate object creation from the actual object functionality. It is 1,000,000,000 times easier to refactor because you can refactor the call method without caring about the things that are getting passed into it. And it is easier to use for both of those reasons. Like the cost of change of that bottom level, the bottom one is way easier than the top one. Other languages like Java in particular is sort of optimized for that top one in a way that Ruby is not. It's easier to refactor that in Java. In Ruby, my experience is that like creating instances and calling methods on instances is like a really clean way to go, and it will improve your code. And among the people who disagreed with this on social media with me about this on social media today was Dave Thomas. So it was very exciting that Dave Thomas made his first post on Blue Sky specifically to tell me that he disagreed with me about something. It was great. It wasn't at all like a waking nightmare. I definitely. So Dave's point, which is actually not more orthogonal to my point than contradicting it, I'll say. Dave's point was that you should push stuff out of objects, and he has come to prefer a more functional style of Ruby, and that can work too. It's towards the same thing of separating out, of like making smaller pieces and building in encapsulation. He's just doing it with functions rather than objects. That's fine. I'm not hung up on it. That's not why I brought it up. Don't put in the paper that I'm mad. I'm not mad. To pull this back, right? We can refactor this code in a couple of different ways to make other changes easier to do, right? So if we pull this is the same checkout action. I've done 2 things to it. I've pulled the data, the like parameters into an initialize, and I'm creating instance variables. And I have also, rather than have a service that calls a service that calls a service, it's all manifest in the top level. I firmly believe that you are generally better off if you have methods that are leaves and methods that are nodes, and you don't have methods that do both. And that was a problem in the existing code. You had a method that was both like doing a thing and passing further on. In general, I find it like a good rule of thumb in factoring that it is a good idea to have one method that like calls all the things and other methods that do the things that get called, and not mix up those levels of abstraction. So this is, I hope this looks a little bit cleaner in terms of like understanding what's actually going on. And it also makes it easier to see it kind of makes it easier to see where the shipping is, and where it might make it easier to see that type error up front. This is actually why my initial reaction to the code was it's a design problem, because I wanted it to look like this, and it was presented to me as a thing that calls a thing that calls a thing. And I was like, I would never do that. Why is that a problem? So okay, this is easier to test. It is easier to refactor. Another thing here is there are very few times in Ruby where you can ensure that something happens before something else. But one of those times is you can ensure that an initialize method is called before any other method is on that method is used. So if you have data validation that you need to have done on an object, you can do it as part of the initialization process, and you will guarantee that that initialization happens before any other use of that. There aren't that many times in Ruby where you can say that, and this seems like a really good one to take advantage of. You can do my data. You're essentially creating a data boundary at the initialize method of the object, so that you don't have to type check everywhere else in the object. You type check when the object is created, and you know the object has to be created before it's used. Okay, so this brings me to, I'm actually going backwards a little bit. This is literal. So literal is a gem from Joel Draper. It got released like a week ago. So I scrambled to put it in because I thought it was interesting. Literal allows you to do runtime checking on the creation of new objects, exactly as we were talking about. And what it allows you to do is it allows you to specify, it's very flexible to allow you to specify custom coercions and validations. So here's what literal looks like. Without knowing what literal does, since I assume nobody here has used it because it just came out, what does it look like this is doing? Like if you saw this in a PR, what would your instinct be that it's doing?
It's using a DSL to define which attributes are expected and handled at initialization, and to make assertions about the nature of those arguments and what can be done with them in terms of like the reader.
Yeah, I think that's about it. Does that make sense to everybody? I'm specifically what it's doing is it's calling these things as properties. It is essentially giving me, notice I don't have an initialize method defined here. It's defining an initialize method for me that takes all of these by default as keyword arguments, I think, but you can specify. And it is doing a type check on creation of the method. Guess what it's using to do the type check? Triple equals. What does that mean you can put in a type check? Any proc. So if you wanted to type check that this only took even numbers, or if you wanted to type check that it only took an integer greater than 0 for a money, you can actually do that in literal. It's extremely flexible. So it has underscore array here, defining the array, is actually a method. It's actually a method that returns a proc. And so it's triple equaling to determine, it has a triple equal test that determines whether the incoming thing is an array of line items. And they're coming out with something that will preserve that type check on all of the array operations that you would do afterwards, which is not part of the gem yet, but will be released soon. So how do people feel about this? Is this good, bad, indifferent? Like if I came to you and I was like, I saw this really cool thing in Ruby Weekly or whatever, and I think we should use it everywhere now. Like, what do you think? I got a thumbs up. I got a hand. Yeah?
it's towards kind of a parameter object or a value object.
Yeah.
Right. And so I'm just going to have that, and that's going to be separate from the rest of the logic.
Yeah, I think that's fair. It's going towards a parameter object or a value object. I think that's kind of an explicit design goal of this, is to allow you to create these kinds of values. It actually has, this is object, but it has an override for struct and for data as well. So yeah, that's very explicitly it. I haven't used this in production yet. I am cautiously optimistic about it as being like a nice sweet spot here, where I get very flexible checking, but not everywhere, but at particularly useful boundaries. I don't know. It just came out last week. Nobody knows. But I thought it was cool, and I thought it was particularly cool because it shows off how you can take advantage of Ruby's flexibility to do something that looks a lot like static type checking, but is actually quite dynamic. So anyways, if you were to run this now, you would get a runtime error at the creation of the object, which means in time to solve the problem. And this is the error that it gives you. It expected a person, it gave an integer. Actually, it should be a string, but I updated some of the code and not other of the code. So okay. I'm going to quickly go through this one because I think it's kind of trivial, and then I want to focus on the last one, and we're kind of running out of time. One option here is you can extract a data object. We talked about value objects. This is kind of very strongly overlapping with things we already do in this particular example, but you could create a checkout model that takes all of those line items and then has its own validity and its own create order and its own subtotal and stuff like that. And then you can use that. So you could, this is the controller. It's creating that checkout model, and then it's passing it to the action rather than passing all 4 parameters. It's passing the object and then calling the checkout object. So the actual object looks like this. It takes in one model and thrown in a success attribute. And then it just keeps passing that through the rest of the values. This is like, I consider this sort of a minor improvement over the previous one because it gives you that sort of initialization check on this object for data validity. I don't know that in this particular case, I don't know that it buys us a lot. I think that there are other cases where it could. One thing about this is that because the same object is going to all the sub actions, you can then call the sub actions on their own and still get the data validation, because the data validation is a function of the data coming in and not the service. That seems like a mild advantage because you can guarantee the order of it. Another thing is that these model classes, you can see I've already thrown in a valid object and a bunch of other things. They tend to sort of attract useful logic in ways that stuff that feels awkwardly attached to one of the services tends to seem, to my mind, more naturally attached to a data object. Your mileage may differ. I generally find that when I create an object like this, I usually find it useful. I usually think that usually sort of justifies itself in terms of the logic that winds up going there. That's not actually the thing I want to talk about. We're kind of running out of time. I don't want to spend a whole lot of time on that one. But I do want to talk about, like, we talked about what is an individual object. What is the entire object system in Ruby? Like, if you were to talk about what, a way that you can conceptualize like a method lookup in Ruby, what is that sort of abstractly? What is happening when you do a method lookup in Ruby? Over the entire object system. Yeah.
I'm not sure how deep you want to go, but I'm not sure how deep you want to go. There's a lot of delegation up an inheritance tree.
Yeah, I kind of want to go is there's a lot of delegation up in inheritance tree. The abstraction that I want you to think of is the entire object system is sort of a case statement. If I'm doing a method lookup, it's not implemented this way, but you could think of a method lookup as being a case statement. If the receiver is an integer, then I call the integer method. If the receiver is a string, I call the string method. It's actually doing this more directly because it knows what the receiver is, so it's actually not doing it like this. But you can think of this like this. And you can think of the fact that this turns it into something where we're using triple equals as type checking. And you can also think of this as something that allows you to offload some of your state and some of your conditional logic into the object system, rather than having this. This is sometimes called ifless programming. rather than have continual if checks against the same logic, you do the if check once and you return two different objects that have different behavior that are called polymorphically. Does that make sense? I'll show you an example. There's a couple of puzzled looks. Let's talk about this. The idea here is something that you might call a constellation of objects. So I just threw in a couple of extra pieces of logic here. So this is the same code with a couple of extra things. So I would imagine like perhaps I want to log nils in my checkout. The buyer is nil, I want to log the nil. If the recipient is nil, I want to log the nil. Maybe I want to create my subtotal based on the tax status of the buyer, whether it's US tax. I don't know, I made this up just to have a case statement here, right? So I have an if statement here based on the state of the world, whether the buyer or the recipient is nil. I have a case statement here based on the state of the world, based on the tax status of the user. And I want to suggest as like the null object pattern. Does anybody know what the null? I'll show what the null object pattern is, and then we can talk about whether my explanation makes any sense at all. What you can do is you can replace these conditionals with classes. So you could have sort of a group of objects. So rather than having a person, you could have sort of the main data is stored in person, but it is surrounded by an object that is like a null buyer, a null receiver, a buyer person, and a recipient person, all of which have separate roles in the system. And you might have logic that depends on whether something is a buyer or a recipient. You might have logic that depends on whether something is null or not. And by offloading that logic into the object system, you can have the actual code that uses that logic be cleaner and a little bit more clear as to what you're trying to do. At least that's the theory. So you can do something like this. So what is this doing? Anybody? Yeah. What? It's a factory. That's true. What does that mean? Yeah, it's determining what class to instantiate based on the input. So this is returning a new class based on the input. The input here is whether it's a person or a nil, or whether it's a buyer or a recipient. And it's creating one of four classes. It's creating a null buyer, a buyer person, a null recipient, or a recipient person. Does that make sense? People looking at this nervously. So then you can do this. So what is this doing? Yeah, it's safely handling your edge cases was what you said. And I like the word safely there. It's maybe generous to call it safely, but I appreciate the generosity. What it's doing is these objects are now all API compatible, right? They all return a method called nilish. They all have a method called nilish. They all have a method called log identity, right? And nilish, nilish returns true for the null objects and false for the quote unquote real objects. The real objects all use simple delegator to back onto the person object so that anything that you call on that object that is not defined will automatically be called on the person object. And everybody's defining a log identity. Note that log identity, the buyer and recipient is literal and not dynamic. It's static. The name, of course, is dynamic. And then, so rather than have this code with this conditional, right? You have a code here that looks like this. So this isn't called they both need to call the role person, and it's not in this line. Sorry, we'll just keep going. They both need to call the role identity to return the new object, and it's not. It's doing it in the initializer, and I didn't put the initializer in the slide. Is it still clear what's happening here? It's calling log identity which also a thing to note here is that the null objects log at warn level and the buyer log at debug level, which means under normal circumstances the null objects will log and the non-null objects won't, but you can switch it. And then you're breaking it out if either one of them is nillish, and then you're continuing forward. The idea here, and I'm not sure that this is the best example to show it, is that the actual logic of this method is clearer and the edge cases are being handled in specific objects. You can do similarly, you can do something here with the tax rate object where you create US untaxed, tax exempt US tax rate or Canadian tax rate objects that in this case, I'm just creating small data classes. They all have their own tax method. And now rather than that case statement, I'm grabbing the tax rate object. In this case, I actually did have the code here right. It's creating the tax rate object and it's just calling tax directly on that object. So the case statement with the complexity of how to classify these things is separate from the how do you use this thing. So you have a very clean how do I use this thing, and the part that's complicated is off to another thing. Okay, so if somebody handed you something like this in a PR, how would you react? Thumbs up, nods. Ben is skeptical. It is adding complexity. It's also taking away complexity. I have tired you all out. You are out of opinions. That is good because we are basically at the end. I just need one more opinion.
What matters to understanding what's going on is very clear here because you've taken away a bunch of this checking and validation.
Yeah. I have to say, I really like null object and sort of these related things. In that gem dashboard code that I was doing, I use this pattern extensively. I have like a null, I have a lock file class that parses lock files. Some of our gems don't have lock files. I have an implicit lock file class that guesses basically, but they're API compatible. So the rest of the code doesn't have to worry whether the gem has a lock file or not. It just calls stuff. So I have stuff like that all over it. And for the most part, I feel like it has really cleaned up the code and made it like easier to manage once you get over the hurdle of like everything is an indirect away. And that's kind of the downside of this. Everything is an indirect away. And one of the critiques of this kind of object-oriented programming is you can never find where anything actually happens because everything redirects to some other object that redirects to some other object. And there are advantages to that. And one of the advantages of that is it actually becomes quite easy to test edge cases because all you need to do is create a class, an instance of your edge case class and pass it through. But there are also disadvantages of that because it is hard. It is a little bit, a lot of people learn object-oriented programming without learning these techniques. They learn object-oriented programming just through the syntax and like the bare semantics of it. And so the first time I think somebody is introduced to a technique like this, there's a tendency to think like, oh, that's really complicated. And I don't know whether it is in practice. All right, we have like only a couple minutes left. And I wanted to get like, I wanted to do, you seem out of opinions, but if people have like, want to say like pros and cons of static typing here or heck, we've got like 3 minutes left. I won't torture you anymore. Here's my list. If people have things that aren't on here. So the things that I think are in favor, good points about static typing. It does still have better editor tooling. It may not forever, but it does right now. And static analysis tools. The code doesn't need to handle edge cases. So all of this stuff about handling nils and null objects and stuff like that all kind of goes away in the right static typing system because nils are just errors. They just don't happen, which also means you need to write fewer tests. And it also means that you probably have more information on the page for the reader about what the intent of the code is. To me, those are the positives. I think there are negatives. I think some people like to say that there aren't negatives of being stricter in typing. I think there are. I listed a bunch of them. I tried to make the list long. Static typing doesn't catch all your errors, and it may not catch the most important ones. If we switched the buyer and the recipient in this code, ain't nothing gonna catch that. Like that's just a problem. That's just a bug. I can't believe I just said ain't nothing. I'm very loopy at the end of this. And I apologize deeply. you're usually in Ruby, you're adding an additional tool. You're adding an additional type checker. You're adding something else. You're adding a dependency, whether it's sorbet or RBS. Like there's an additional depending. There's more typing in the physical sense that you are typing more characters, which can lead to more bugs and more tiring. Yeah. It's okay. Fine. And sometimes you have more complexity. Sometimes you have to add complexity to the code to convince the compiler of something that you already know about the code, but the compiler or the static type system can't figure it out. You know this thing's not going to be nil, but you have to convince the compiler of it. You know that this thing is something, but you have to explicitly cast it. That can be a pain. It can be harder to test static typed code because it can be harder to create edge case conditions. Like there's a real problem here that is like, I come to call like the 99% problem. Sometimes you put constraints on code because you think they're 100% constraints and they actually turn out to only be 99% constraints. And then you have real problems because there's no way to do this thing that you have to do because you modeled it as being an impossible situation. That is super easy to do in static typing. And you need to sort of argue against that. You need to work, it's hard to test against that. Specifically within Ruby, a lot of metaprogramming and flexibility is harder in a static type environment. That is by design, like they're trying to make it harder. And this is like a hot take that I can't quite prove. My experience here is that people who are like heavily used to static type languages tend to be less aggressive about object-oriented design. And so you tend to have like longer methods, more nested if statements because they're sort of depending on the type checking to sort of catch errors in this case. I'm not like 100% convinced of this. I'm maybe 60 or 65% convinced of this, but I do think there's something. I do think that there's something there. But I don't know. I could be wrong. I'm frequently wrong. So one of the side effects here is I think that this has different values for different teams. One of the clear benefits of static typing or these kind of runtime checks is it limits the amount of damage you can do in code that you are unfamiliar with. Because you will hit a wall much faster in unfamiliar code than you would otherwise. And if you have like a very big team, or if you have a team with a lot of new developers, like that can be a big win. If you are not under those conditions, like that can be a problem. All right. So I wanted to leave you with one quote from this book, The Imposition of Unnecessary Obstacles, which is actually book 2 in a series of really cool science fiction murder mysteries. I looked at the platform precarious in any way and wondered again at our human tendency to romanticize the imposition of unnecessary obstacles into our lives. And I thought if there's any group that romanticizes the imposition of unnecessary obstacles into their life, it is developers. Please try not to do this. Like there's a lot of complexity, and if the static type is adding complexity that is unnecessary, please try not to do it. If dynamic typing is adding complexity that you don't need, don't do that. But try to figure out where the necessary and where the unnecessary complexity is, and try not to do the unnecessary. That's terrible advice on some level. Don't do bad things. But think about whether there's a tendency as developers that we think of complexity as a really cool thing to plow through rather than a thing to kind of route around. And try to be more of a route around, mindset. And that's it. I'm back to the self-promotional slide. This is where you can find me on the internet. I think I spelled Mastodon correctly this time. I genuinely appreciate your time coming here at like this sort of awkward time in a conference. I'm sure you're all tired. I very much appreciate your participation and your like eagerness to be here. Thank you so much. I hope you have enjoyed the conference so far and that you enjoy tomorrow. And I'll see you around.